Welcome back to Hardware Unboxed for part 2 of our September Q&A series. If you missed part 1, it will be on the channel ready for you to watch right now. But more questions that you guys have asked, some really great stuff. So without further ado, let's get into it. But before we get into it,
today's sponsor spot is brought to you by ZimaBoard, the world's first hackable single board server for creators starting at just $120 US. It's created by people who grew tired of reoccurring fees, unfriendly presets, and isolated systems, so they set out to make the home digital experience more attractive and more affordable. ZimaBoard has the expandability of an x86 SBC with the power of a microserver. It allows you to set up a 4TB personal cloud in 5 minutes, configure a secure VPN to protect your digital footprint, tune your network with OpenWRT and pfSense, build a 4K media server that runs with Plex, share and collaborate with team members on your files, or upgrade your smart projects across different systems. So for more information, please check the link in the video description.
do gamers actually want GPU competition for Nvidia to buy the competitors' products, or do we only want competition to keep Nvidia prices in check and then buy Nvidia anyway?
Deep. Pretty funny though, and possibly the case in a lot of instances. Because obviously competition's good, it does drive down prices. We've said that time and time again, and we've seen evidence of that recently.
That's right.
Obviously with the 4060 Ti and the 4070 both dropping $50 in price due to the release of, I'd say, mostly the 7800 XT. But yeah, I mean, obviously we can't really answer that question, but Nvidia does generally outsell AMD quite comfortably. So yeah, I mean...
Yeah, it does seem there's a bit of like Nvidia releases these really poor value GPUs and everyone's complaining about GPU prices, but then no one actually wants to consider the competition products. Like the complaints have always been the 4070 shouldn't be $600. It should be $500 or less than $500, whatever price you want to make it. It's not like, oh, the 4070 is $600, therefore I want AMD to come and produce a $400 GPU that I'm then going to buy. It's always sort of I still want the NVIDIA feature set at a lower cost. And so something needs to be, I guess, doing that. And it's not going to be NVIDIA because they want more money. So it has to be some sort of external pressure. So yeah, I think there's some element of truth to that. And we've sort of seen that with sort of this whole competition side of things. You see prices drop a little bit and people sort of head more towards the GeForce team, but really that's just on AMD, really. Like AMD's got to be convincing people that if they're providing competition, it's not just to lower NVIDIA GPU prices, it's to make a product that's compelling and is worth buying. And there's got to be a point where, you know, AMD's maybe sacrificing on margins or something where NVIDIA doesn't want to go down to that level. So AMD does end up being the more compelling choice, because if a 4070 can drop by $50 or so, then fine, maybe that makes NVIDIA more competitive. But there's going to be a point where NVIDIA can't just keep dropping the price further and further and further. It's going to go against their sort of goals. And I feel like the last couple of generations, Radeon really hasn't been offering that sort of over-the-top, extreme good value and the competition to the level where you would definitely just buy the Radeon product. It's always been sort of this toss-up in a lot of areas, and I think we're seeing that now with the 4070's recent pricing adjustments. So, yeah, hopefully they sort of learn from our reviews and things that a bit of extra competition would be nice.
We talk a lot about games that are poorly optimized. How would you define a game that has excellent optimization? If there were an award for the best optimized game of 2023, what would it be? What criteria would you use? So yeah, we've touched on this a lot. Obviously, good optimization is a game that looks good and plays well, and probably has a lot of customizable options on PC. You know, a lot of the basic stuff with a lot of the advanced stuff, and probably scales really well. Sort of like what we see with a game that's been around for a while now, like Cyberpunk 2077, for example. Recently been testing that with the Phantom Liberty update. And it's cool to see that that game can be scaled down quite well to work, at least on slower graphics cards. I haven't done much CPU testing, I guess, but you can lower things like crowd density and stuff like you sort of can do in Hitman 3, which sort of reduces a lot of the CPU overhead there. So yeah, games that scale well across visual quality settings, which is something we didn't see with, say, Starfield, for example, and doesn't have any other isn't plagued by issues such as like traversal stutter and stuff like that, for example, which is also a bit of a weird one as well because especially with these PC ports, because that can be tied to almost like the frame rate. So if you play at a lower frame rate, you're less likely to encounter that. But then if you play with like high-end PC hardware that it wasn't necessarily designed originally for, it can introduce a lot more of that. But that's still an optimization issue, right?
Yeah, I think it's obviously a very subjective metric because a lot of what we're talking about is like the visuals to performance ratio. So when a game runs well and looks good, that can mean many different things depending on the genre of the game. And I think, we still need to be aware that different types of games are going to be running differently. Like an open world game with a lot of NPCs and AI and things going on, a lot of different systems, is going to be more taxing on performance than, let's say, a first-person shooter that is run largely in indoor corridors,
like
for example.
Doom, for example.
Like Doom or like, one of those sorts of games. So, I sort of would largely be trying to compare across similar sort of games. So when we're sort of talking about the optimization of Starfield, for example, we want to be comparing it to other open world role-playing type of games that have a number of systems. We don't want to be comparing it to fighting games, for example, because then we're going to get into a whole sort of different discussion there. It's going to be, not going to be great. So, I agree with most of what you've been saying about how, it's largely on sort of the visuals to performance ratio, avoiding major issues, including, features that I would say is sort of key for PC, things like FOV sliders, which again, we would have thought is a basic feature, but games like Starfield come out and don't include that. And just generally scaling well. I like to see, generally when I'm testing a game, I like to see at least a 2x performance improvement from ultra settings to low settings, which tends to provide, and this is without factoring upscaling, so just simply by turning down graphics quality, we can get double the performance. That tends to make the game very playable across a wide variety of GPUs, which tends to improve the experience for all. I think as it comes into more games in the future, we will have to start looking into things like, are games being optimized for, say, high VRAM amounts? Like if you are buying an RTX 4090, is the game being optimized for higher VRAM buffers by including higher resolution textures? Because generally speaking, you can just include high resolution textures without a performance hit for cards that have enough VRAM. So that could come into optimization as well. It's like, is this utilizing high-end hardware to an acceptable degree?
Yeah, and I guess that's like I gave the example of Cyberpunk, but Cyberpunk is very underwhelming when it comes to texture quality because it's designed to work on 8GB cards, even with ray tracing enabled at a fairly high level.
Yes.
So that's an unoptimized aspect of Cyberpunk, is the fact that the textures are generally pretty muddy, pretty flat. It's very selective in what textures it loads in high quality and what ones it doesn't. Viewing distances are quite poor in terms of texture quality. So for a high-end modern PC game, that's something that they could have improved a lot. And like when you see games, like I think the Star Wars Battlefront games, they really pushed and improved texture quality for terrain and stuff when they first came out. They were quite clearly better than a lot of other games, if I'm recalling correctly.
I think so.
So texture quality is a way to enhance a game massively, and I've always argued more so than what we're seeing at the current level of usable ray tracing. I find that higher texture quality is something that you like straight away. It jumps out at you and it makes the game look a lot better.
That comes into optimization because, again, like typically you can increase textures without much of a performance hit. So an optimized experience for someone that has a 16 gig or 24 gig GPU is a higher texture quality. And again, it goes all sorts of different ways. Like, yes, it might be nice to have ray tracing, for example, that is enabled, that's available for high-end GPU users to use, but if the quality of the ray tracing is really bad, like we might see from an F1 game where really you can't notice the difference, or from a Far Cry game where you turn on the ray tracing and the quality of reflections is abysmal, that comes down to, could they have done more for higher end GPU owners in that sort of game to improve the quality of ray tracing to make it more noticeable and therefore more worth using? So
imagine how good Cyberpunk would look. Because, I know path tracing, it's kind of a tech demo and it's advertised as such from CD Projekt Red. But imagine turning that on and then having the texture quality twice what it is.
I think that would be like
the game would be phenomenal.
I feel like if it nailed all those things, a game like Cyberpunk would be the ultimate optimized game because it runs quite well on lower tier GPUs, and even the low settings, in my opinion, look quite good in Cyberpunk. Like, it's not like, unless you manually turn off things like shadows, which I believe you can do in the game, as long as you're not doing that, the game still looks very good. But then it could scale right up to a 4090. It could be utilizing its full 24 gigabytes of VRAM. It could be running path tracing. It could be using all those AI features that we've talked about in previous questions, and that would be sort of the ultimate optimized experience. So again, don't want to dismiss Cyberpunk, because compared to a game like Jedi Survivor that has extreme issues in terms of crashing and traversal stutter, or a game like Starfield where you're forced into using upscaling because the quality settings just aren't there, like Cyberpunk is well above those games. So yeah, I don't know, like
it got there eventually.
It got there. Well, yeah, I mean, we should be talking about the Cyberpunk experience today, because back when it launched, it was sort of a different discussion in terms of the quality of the game and its stability.
It was Battlefield 2042 buggy.
Yeah, that's right.
All kinds of issues. But it's in a good condition today.
It's hard to sort of say like what game we would class as well optimized, because I think you could make arguments for many games that there's all sorts of different areas where maybe it's not as optimized as it could be, and maybe our standards are too high when we're sort of saying a game needs to hit all those checkpoints to be well optimized. But
you can dream.
Yeah, I mean, I would certainly prefer things like traversal stutter to not be there over, I guess if I was taking like traversal stutter or high quality or low quality textures, I would take low quality textures, because traversal stutter is kind of game breaking in my opinion. But again, it comes down to the balance of things and where you place your importance in the sort of visuals. So yeah, it's a hard topic, optimization. Hard topic. Do you think game devs should offer graphics quality presets that go beyond just medium preset equals everything on medium, and actually tune the settings for what offers the best balance between performance and visuals in their presets? So more like a optimization guide sort of preset options. I think I get where you're coming from. Like, ideally, some of the medium presets would offer a more tuned experience for gamers that have reasonable hardware, but the presets they're kind of about optimizing the game for a wide variety of gamers. So they're going to have to take into account not just people that have mid-tier GPUs, but people that have mid-tier CPUs and less VRAM and less system memory and things all into those sort of preset considerations, because they don't want to have like the ultra preset and then the medium, but you've got a good CPU preset, and then the medium, but you don't have a good CPU preset, and then the low preset, but you've got a high-end GPU but a low-end CPU. It gets very complicated there. They're trying to go for a one-size-fits-all. You turn it down to medium, and if you've got sort of mid-range hardware all over, then the game is going to run a lot better, because it would be disappointing if you didn't have that CPU power and then you turn down to the medium preset, it does absolutely nothing. You'd be like, what's going on? Like, I've turned it from ultra to medium. Why isn't my game running better? They have to account for a lot of different hardware configurations, whereas the optimized setting things is sort of assuming that you're more of an enthusiast and assuming that you've got sort of a configuration and a system that maybe is more standard and more typical, whereas developers are sort of deciding for a different audience to that. So maybe it'd be nice to have like the optimized or auto settings that can tune each thing individually based on the GPU and CPU you have. Some games have done that, but as far as presets are concerned, they still need to be catering for the wide audience, which unfortunately means things like textures will be unnecessarily turned down for a lot of those presets. Just go in, crank those things up, and you'll generally get a good experience. How do you think the frame generation war is going to end out? Now that AMD has confirmed a fluid motion technology that works on older GPUs and that is implemented via software, so no special hardware is required, do you think Nvidia is going to fight back, introducing maybe a lighter version of frame generation on older RTX cards? They also have dedicated hardware to work with, although they claim that it is not as optimized for this as the Ada Lovelace architecture, like what happened with FSR1 and NIS and all those sorts of features. So, I think we're both reasonably concerned about this, because there is a pathway to a future where both companies are advertising big FPS numbers on charts with long improvements and big numbers, but then it's all obfuscated by crappy, low quality rendering techniques.
Mhm.
And I think the way that AMD was advertising, say, the Fluid Motion Frames driver implementation certainly has me a little bit concerned there about, are we actually caring about visual quality when we're showing that a card can run at 200 FPS? Because that 200 FPS number could mean rendering at 720p with upscaling, with generating awful looking frames in between each frame. They might be running with like Radeon Boost or some other, like you move your mouse and the resolution cuts technology. And we end up with this image that looks awful, but then the frame rate is super high, and that's being used in advertising because they're claiming that's 4K with FSR3 technologies, but the actual image is not good. Like I'm certainly concerned about that sort of marketing in the future, where again, like they're trying to convince people that this feature is gives you equivalent image quality, which may only apply in certain circumstances, and then applying that to all these other situations and stacking technologies on top of one another, which has questionable quality. It's I'm not super keen on that future for advertising. It's not going to be good.
Yeah, not going to be good at all. I don't know what we do about it. It seems like that ship sort of already sailed, and that's the trajectory we're on.
Yeah,
but
what can we do about it?
I have no idea.
Not much. We'll have to see how that one plays out. But yeah, we'll see. Currently, GPUs are getting more feature-rich. It's not about hardware support for common APIs anymore. When someone asks for what to buy, it's getting to the point it's Nvidia unless proven you won't do VR, streaming, AI, Blender, video editing, ray tracing, using DLSS and reflex and things. Isn't this getting a bit hilarious for AMD? You sort of have to go through a checklist of things you won't be able to do and verify you will never do those things.
I think some of that's true. I mean, VR I have no idea about because we're not interested in VR at all. Streaming, I've definitely done some streaming on a 1700 XTX and found it as good as the RTX 4090. In some ways it was more stable with AV1 anyway. So not sure about the streaming one. That's not something we're like, I don't know, experts in, for lack of a better term. We don't spend a lot of time testing and comparing, but the streaming I've done with RDNA3 was really impressive with AV1. But maybe there's stuff there that we're not aware of. AI, it's like, okay, Blender, for some video editing, I guess. I mean, we use Adobe Premiere, and we actually use Radeon GPUs exclusively for that.
I use a GeForce GPU.
Well, Balin and I use it.
Really.
I've tried both, and we've not really found any performance differences with stuff like warp stabilization or encoding or just scrubbing through the timeline. All seems about the same, but we don't use the GeForce GPUs because we constantly run into problems with multiple monitors, with like monitors flickering or dropping out. I don't know why that problem still persists with RTX 4090s, but Radeon GPUs are flawless in that regard. So we've definitely had a better experience there with the Radeon GPU. So there are some things that they're definitely better at. Playing RT, it's like, okay, well,
I feel like this list is a lot of like when you read the list, right, of all these features that Nvidia does better, it's a long list. There's a lot of things, right? But then there's a reasonable argument that can be made that buyers are not necessarily doing any of those things. Like if you're just a person buying a GPU for gaming, like these are gaming GPUs, they're not as much geared towards production work, although you can do production work on them. Like a lot of people are building these systems just for gaming. So things like Blender rendering being superior on Nvidia GPUs, which I'm pretty sure is the case based on other benchmarking, a gamer may never do that. A gamer may never use it for video encoding or things like that. A lot of people don't stream. A lot of people may not be using AI workloads on their desktop graphics card. Like there's a lot of people that just want to play games. So yes, there are some people who are going to be using their graphics card for a lot more than just gaming, but I feel like there's still a large target market of people for this type of graphics card that is just doing gaming or very gaming related tasks. And as you say, like streaming, I think is probably the closest to gaming related task of that list, as well as I guess VR. And it feels like that, the quality differences, at least today, are sort of similar enough, maybe. Maybe we'll have to look into that a bit more. But
I mean, if you're tossing up between like a 7800 XT and an RTX 4070, and the 4070 is $50 more, a lot of those, and you're you're gaming, you're buying it to play games like what Tim's talking about. It's like, yeah, okay, DLSS generally better quality than FSR. How big that gap is and how much you should weigh on it, hard to say. And then ray tracing, frame generation as well. Let's throw that in there. Like, this is why reviewing graphics cards today is so difficult, because if you're predominantly playing multiplayer games, you play Apex Legends, Call of Duty maybe, Fortnite, any other of the thousands of multiplayer games I could list, you're definitely not caring about ray tracing at all, because you just shouldn't, or unlikely to be playing with ray tracing enabled in like Fortnite, for example. You're not playing the game to win. If you've got ray tracing enabled, that's going to do you no favors whatsoever. Frame generation is absolutely, completely useless for those games. I don't think that's really up for debate. So those features are kind of, for all the people that mostly play multiplayer games, those features are now sort of null and void. And then it comes down to which ones offer the best rasterization performance. But again, like Fortnite, Radeon GPUs aren't always the best there. Some updates do break performance, create a lot of stuttering. GeForce GPUs are definitely a safer bet if you're playing like Fortnite. But then if you're playing Call of Duty, for example, maybe Radeon GPUs, they do generally offer a lot more performance. So it does come down to the games you play, the type of, the style of games and all that sort of stuff. So it's difficult. But yes, Nvidia has a big advantage in terms of features.
I think it's like
overall.
I think it shows like how, I guess maybe a decade ago you could go with a more one-size-fits-all conclusion to a GPU review, where we're largely just talking about rasterization performance. So the faster card becomes the obvious choice. Whereas today there are so many different factors that go into it. So I think, someone who's reviewing a GPU that sort of says something like, you have to buy a GeForce GPU because it's better at ray tracing, there are buyers out there where that is not going to apply to them.
A lot of buyers.
There's going to be the exact same thing where if you said, well, a GeForce GPU is better at Blender rendering and video encoding or something, there's going to be a whole section of buyers where that doesn't apply to them. So it becomes... That's why I guess your conclusions in your reviews are so long now.
So hard now.
You're talking about rasterization performance, ray tracing performance, features. We don't really cover the workstation side of things as much, so that's more of like another reviewer is going to dive more into how does it go for Blender and AI workloads and things like that. But for example, if I was buying a GPU, I would not be factoring in Blender rendering or AI encoding or
streaming.
I don't stream at all. I'm not super interested in multiplayer gaming, so I would be more highly prioritizing ray tracing and DLSS quality and those sorts of things.
But that also depends on the price range.
It does.
If you're buying an RTX 4060, how much do you care about ray tracing?
Yeah, not as much.
Like, probably not at all.
And DLSS is less, the quality, the range of qualities for DLSS at 1080p is a lot less large as you would get at 4K, but the performance mode at 4K is a lot more usable than at 1080p. So, it becomes this, I guess, reviews have to become this thing where we're giving you all the information, and then ultimately you need to decide which of the features are things that you're going to be using and then weight that appropriately. We're always going to give our opinion on things like our use cases. So, for example, I feel like in a lot of your reviews, a lot of your conclusions are about the games you play, like multiplayer games, which is a perfectly valid sort of take. A lot of people play like that. I feel like if I was reviewing those cards, my take would probably be slightly different because I swing more towards single player gaming. I imagine someone who does a mixture of gaming and productivity work is going to have a completely different take, which is why it's good to look at all these sorts of different reviewers to get their sort of opinions from their sort of perspectives, and ultimately hopefully all these reviews will show all the different areas. So it definitely gets... It's definitely difficult, and you could definitely make the case that if you want the most feature-rich GPU, that it's hard to go past a GeForce GPU, but then again, some people may not value those features. So,
in any case, though, it's why we've said that there's a penalty for AMD there. Like, they can't be close to Nvidia for similar rasterization performance. They can't just go, we're basically there, knock $20 off or something like that amounts to like 5% or less than 10%. They have to be more than 10% cheaper, probably at least 15%.
I think so, because it closes down their target market, doesn't it? Because if they're pricing it too close, then the only market of people who are going to be interested in buying the product are people that are discounting all the features. So maybe it's pure gamers or multiplayer gamers or some group of people. Whereas the lower they go on pricing, the more the people who are interested in those features are going to start tossing up, like, do they value and pricing over the feature set? And I feel like, again, a lot of Radeon GPUs haven't necessarily made that decision as difficult as it needs to be.
Yeah.
Like, they need to be getting into people's minds, like, you should be tossing up between this versus this based on all these features, whereas the current pricing is sort of like, well, it's 10% more to go Nvidia. Nvidia offers this long list of things that they do, so it becomes the obvious choice. So I think, yeah, certainly if they can't compete on features, they can't add in improved AI rendering and improved video encoding and things like that, then yeah, they need to improve more on the pricing side. Do you think Nvidia overstates the PSU requirements for their 40 series? I've seen a lot of subreddit questions on people wanting to run 550/600 watt PSUs with the 4070.
Right. Do they overstate it? I don't think so. Like, it's better to overstate it than understate it, that's for sure. And you've first of all, if your system requires, let's say, 400 watts, you don't want a 400 watt power supply. You need some headroom there. You don't want to be running that thing at maximum load all the time. That's not good. It'll certainly reduce the lifespan of your power supply, and it can cause instability issues with like voltage loading and things like that. So
you get a spike and it's suddenly well over the load.
Or it's got to balance that across certain rails and stuff as well. So depending on the quality of the power supply, which is the next thing I was going to talk about, because depending on the quality and the efficiency levels of your power supply. So basically 600 watts isn't necessarily 600 watts depending on the load, the ambient temperature, all that sort of stuff can factor into it. So they've got to give themselves a nice buffer there. So if someone buys just absolutely garbage quality 700 watt power supply, it should work if they're only needing around 350 to 400 watts. So there's quite a few factors there to consider with power supplies.
I think on top of that, the specifications and the requirements are listed specifically to get Nvidia out of trouble. What they don't want is, as well, someone who has like a Core i9-13900K that's using 300 watts and then 20 hard drives, 20 fans, which all use all this power.
It's like a Corsair 1000D fully stocked.
Yeah, exactly. Like, they don't want all these peripherals in their system. And then Nvidia, they've only recommended 500 watts. The GPU may only be 200 watts, but you've got 400 watts of other stuff in your system. And then suddenly, there's all these sorts of issues with stability. They want to make sure that even those extreme systems, there's enough headroom to run your CPU and all your other components and the GPU within the rating. So yeah, if your system is on the lighter end of the scale, you've got more efficient components, you don't have 20 hard drives and 20 fans, then yeah, you can generally cut down a little bit on the power supply requirements. But then again, typically, you're going to get better efficiency with high quality products. So
they're factoring in system configurations and then power supply quality. Would be probably the two main things. Actually, I want to go back and change my answer to the question where it was like, what is frustrating about your job? I'm not sure if that was in this Q&A, but at some point I was asked that question. I gave an answer because this was frustrating. Okay. Very annoying. So the question is, and actually the question's not necessarily about this, but I'm going to change my answer. Has Steve recovered from the price of the 4090 Matrix? So a bit of a joke question there. We said it was $4,000 US, which is not correct. It's actually $3,200 US, which is still quite the price that you need to recover from. So yeah, haven't recovered from the price to answer the sort of the joke question. But the frustrating part was, actually there's a lot of frustrating parts of the 4090. Now I shouldn't rag on ASUS too much because, they provided me the sample. Wasn't something that I really asked for, but they said, we've got one. Do you want to look at it? I'm like, yeah, sounds interesting. Liquid metal. Sounds like a pretty cool graphics card worth checking out. So they sent one over. I had it about 3 days before the embargo was to lift on that product. I had no information. They provided me nothing with it. I didn't even have the updated software to use with it. So I had to send them multiple emails and there was a bit of back and forth and we didn't really get anywhere. And then the day before the video was set to go live and I was wrapping it up, they gave me the price. So I said to them, what is the MSRP for this graphics card? Which is a pretty standard question I have to ask, a lot.
You'd be surprised how often you have to ask for the MSRP in US dollars specifically, because they often only have AU pricing or something. But it's a
lesson learned on that one.
Yep.
So someone from the team replied pretty quickly and said the MSRP for the ROG Matrix Platinum 4090 is $3,999, so $4,000, and they put US at the end.
Mm-hmm.
So I was like, okay, well, that answers my question. I asked what the MSRP was. They said the MSRP is $4,000 US. So that's what I went with in my video. Turns out that was misinformation. I pinned a comment. I made a post on the community tab to try and clear up any confusion there, because obviously we want to give you guys accurate information. Thankfully, it didn't change anything about the review, because that would have been, if I had to delete the video and do it again because the price was quite wrong, I would have been very upset.
YouTube, please give us the swap out the video / audio feature, because that would really help us out in situations like that.
We want the LTT treatment. Anywho, so basically you must be sitting there thinking, so why did they tell you it was $4,000 US? Well, for some reason, they converted the Australian price, which includes shipping and Australian local tax and all that sort of stuff. So they converted it's like 6,800 AUD, so Australian dollars. They took that and like backwards engineered it and converted it back into US dollars, which works out to be 4,000 US because it includes Australian taxes and shipping. But it's not the MSRP, because the MSRP is the US manufacturer's suggested retail price.
Oops.
So
that was frustrating.
So look, they rang me, they apologized, they owned the mistake. They said, it's our mistake. We're sorry. That one's on us. But yeah, it was a bit silly of our review to give you guys the wrong price when we specifically asked ASUS for the official price. So that's what happened there. So that was frustrating.
Yes.
That was frustrating because I tried to do the right thing and get the official pricing from the horse's mouth, and they went and gave me a weird price that makes no sense in any region. So anyway, moving on to the next one. What ended up being the official solution to 4090 power plugs melting? Well, I know they made, I believe it was they adjusted the length of the sense pins, so it had to be pushed right in, or the sense pins wouldn't do their thing, and then it would act like the connector's not connected, is my understanding. So you had to really jam that thing in there, which is ideal. But yeah, I mean, I honestly still don't really know how much of a problem this was, how widespread. I mean, we've got about 4 4090s in pretty much daily use, and I've checked the cables once every couple of weeks. I just jam it in there. I do push it all the way in, so I do that. But some of them are using like the adapters, and they're just all over the shop.
Yeah,
it's a complete mess. My test system one, my test, I've got the same connector I've used from day one. The same. It's a 4/8 pin into the 12 or 16 pin, whichever way you want to call it, but the high powered connector. And I've used the same one. I reckon it's been plugged in and unplugged well over 100 times. Like well over. I've done it 3 times today, just when we were setting up that Cyberpunk system. So hundreds and hundreds and hundreds of times, and like they're all bent every which way, and no problems whatsoever. Never had a melted connector at all in any of the systems. So
yeah, I think like a lot of these
it's
things,
hard to do.
It's probably going to be a compounding set of factors. Like I know some people have blamed user error as sort of the
Gamers Nexus said that, and people got a bit upset. And
yeah, but I think like things that can compound user error are a poorly designed connector. Like if it's not obvious how far plugged in it is, or if it's too small to adequately. Having said that,
that's not even really my analysis or my opinion. Like you just get it, you push it in, and it clip. I know, like Gamers Nexus even showed that it doesn't make a really distinct click. It's not as good, but
I mean, if you're talking about like an edge case user where someone is like, maybe they weren't even plugging their 8 pins in properly, but that wasn't as much of an issue because it's easier to get away with a bad plug on an 8 pin, and then they're doing the same technique on a 12 pin, and then it doesn't work and it melts their system. Like that's possibly, like that's both a bad design and user error at the same time. It's
That's
the user's
true.
fault for not plugging it in, but it's the connector's fault for not giving the user the feedback they need to know that it's plugged in properly.
It's a tough one. It's a tough one because you could argue that if you're, and I know PC building is now it's like buying Lego. It's pretty mainstream and meant to be pretty simple and foolproof. So there's that. I mean, because I've been doing this for over 20 years now, I've come from the days where like a professional technician must install this component. And I don't want to piss people off in the comments, but plugging these connectors in correctly is dead easy. Like you just, but again, like I've had some mates who aren't, I don't know if competent PC builders is the right word, maybe experienced.
So Steve has called his mates incompetent?
They're idiots. I've had some friends who like dabble in PC building. Like
Ex-friends now.
Yeah. They won't watch. They don't watch my.
Okay.
They hate my content. It's fine. I'll just get to this. All right. Stop talking. You know, they play around. They upgrade their graphics card. Like their experience level is, I upgraded my graphics card 3 years ago. You know what I mean?
Yep.
So they can do the thing, but they don't do it every day. And again, like you could argue that because I've done it probably close to 1,000 times now that I'm not. But they'll like put their memory in and they'll put it in the slot and they'll push it down and they'll like do that, sort of like what you saw Tessa do in the build. And they're like, okay, that's in now. And I'm like, mate, you got to get it and, get the hammer out. But no, you've really got to be quite forceful. It's got to be very direct force. Like you know, when my daughter Tessa was grabbing the memory, and because she's only 9 years old, she's pushing as hard as she can. But because she's pushing as hard as she can, she's like wobbling them, which you could easily just do a hell of a lot of damage to the DIMM slot doing that. So it's very direct force. And yeah, when friends come over and they like put their new graphics card in, I'm like, mate, and it pops in. So you do have to apply a surprising amount of force for installing things like memory modules or power connectors. And even like 24-pin connectors, you know, they require quite a lot of force to get in properly. So it's not, I don't know where I stand with this. Like you sort of got to be pretty experienced, know what you're doing to install a high-end, well, just any graphics card. But could they have made the connector better? Yes. Is it better than what we had with the 8 pins? No. Was that solution fine and worked? Yes. But also they are neater and I do so in my test system, I've got one of the high power connectors and then I've got like 4 8 pins. And when I get to install like a GeForce card that uses the one, it's like, this is such a luxury. You pop the card in, clip, done.
Yep.
And then
you've
got like the 6 pins with the extra 2 pins next to it, and you've got to put 3 of those in a row, and you've got to like try and awkwardly hold them in, and then the more you put in, the harder it gets. And it's like, yeah, so now when I have to like install a 7900 XTX, I'm like, here we go. So there's cons and pros. Anyway, I've probably pissed off a ton of people with my answer on this, so let's just wrap this one up.
All right, and that does it for part 2 of the Q&A series. We will have a part 3 on the channel. I think we've got plenty of questions that we still want to get to, so well worth sticking around for, in a couple of days, we'll have that episode up on the channel for you to watch. Podcast as well, if you do appreciate the Q&A series and like the sort of discussions that we have between us, we've got our new podcast, separate channel. You can also get in your audio feeds as well. You don't have to subscribe to YouTube if you'd rather not do that, but yeah, just more casual chats on a weekly basis between us. It's a bit of fun there. We've got our Patreon float plane if you want to sign up and support the channel and the testing that we do, and you'll get some cool bonuses in return, like our exclusive Discord community, our monthly live streams, BTS videos. There's some Q&A opportunities, probably some more things with the podcast as well that we might try and do. So yeah, well worth signing up, and that's pretty much it. Thanks for watching the whole episode right to the end. Really appreciate it.
MVPs.
Yeah, I'm your host Tim.
I'm your host Steve.
See you in the next one.